welcome back to Cal's Prep. Today we're going to continue our discussions on geometry questions found on your SAT Math section. We are going to focus in on triangles as well as circles. Hopefully we will clarify a few definitions and traits of both of these geometric shapes because they are heavily questioned within your SAT Math section. So let's go ahead and first begin our discussion with the measurement of angles. Now, your angles are going to be in measures of degrees or they're going to be in measures of radians. There is a really simple conversion. If you're given x degrees, any x degrees, you can find the corresponding radians by multiplying your x degrees by the ratio pi over 180 degrees. If, on the other hand, you are given theta radians and you want to convert them to degrees, you will take your theta radians and multiply it by the ratio of 180 degrees over pi. Quick note, pi is a mathematical constant that exhibits the relationship between the circumference of a circle and its diameter. As you can see by this cute little animation, we have the diameter of our given circle set to 1, and the circumference eventually rolls out to the pi. Now, the circumference of any circle can be found via the relationship 2 pi r, where r is equal to the radius of a circle. A quick note, interjection there, is that the center of any circle is going to be the point that is equidistant from any point along the rim or circumference of your circle. And the distance between your center point and any point on the circumference will be equal to the radius. So remember, circumference 2 pi r, r is radius, which is the measurement from center to outside rim circumference. Now, if you are given a full rotation about the center of a circle, the complete rotation will measure 360 degrees, or it will measure 2 pi radians. The three angles of any triangle will always sum up to 180 degrees, or pi radians. A quick note, if you are given something like a unit circle, you may be given either degrees or radians in the negative rotation. If you're working clockwise about the rotation along the coordinate plane. But we'll get to that when we get there. For now, let's remember center of a circle, radius of a circle, diameter of a circle, circumference of a circle, and moving into the formula to find the area of any circle, let's understand that you can do so by finding pi r squared. So multiplying that mathematical constant pi times the radius squared. For any sector of a circle, it's going to be easy to imagine your full circle as pi, P-I-E, not P-I, and any sector is going to be a slice of pi, cut from the center outward towards the circumference, or if you'd like to remember it by understanding that any sector on a circle is going to be enclosed by 2 radii stemming from the center and connecting to the circumference. Now, if you have a given sector such as that, you will also be binding an arc on the circumference, and that arc is going to be within the segment, either the piece from point to point that makes it the shortest distance or the longest distance all the way around. And they will have different ways of writing down the arc depending on if it's the small way around or the large way around. Now, moving on, let's understand what a tangent is to a circle. A tangent line to a circle is going to be a line that touches the circumference of a circle only once, doesn't intersect it, but rather meets it at such a point that a radius drawn directly to that touching point for the tangent line is perpendicular to that tangent line, meaning it has an angle measure of 90 degrees or pi radians, rather pi over 2 radians. So here to my left, I have a circle sectored off, if you will, with corresponding percentages. And I bring this up to highlight a key point. The most commonly asked question regarding sectors for circles will either ask you to find the area of your given sector or the angle measure of your given sector. Now, if you know either, you can find both. Because the percentages outlined here give you a hint as to what I'm getting at, when you find the ratio or proportionality of your given angle, let's say, to the full angle of your full circle, you will also find the proportion, you will also find the proportion of your given sector's area compared to the full area of your circle. Vice versa is also true. If you're given the ratio of your area for a sector compared to the whole area of your circle, you now know the percentage or proportionality ratio for your angle as well. Moving on, let's discuss some key traits and terms for triangles. Vertex is going to be any corner of a triangle, and more than likely when they ask you a question regarding vertices, or vertices rather, it's going to be the angle measure of your given corner in a triangle, your vertex. Any leg of a triangle is going to be a side that is not directly opposite a 90-degree angle. So if you have a right triangle, for example, that 90-degree angle will have a side of a triangle opposite it called a hypotenuse. The hypotenuse is a special side of a triangle, and we'll get into more special traits of a hypotenuse later in. For now, let's understand vertex, legs, and move on to different kinds of triangles, specifically equilateral and isosceles. Now, you can't have a right triangle that's equilateral, but you can have a right triangle that's isosceles. That is because equilateral triangles have equal legs, legs of equal length all around, which means that their angles are all equal. But that only occurs, remember, because we have a full 180 degrees in any given triangle. If they're split equally, then we are going to have 3 vertices, so divide that 180 by 3 to find that each angle in an equilateral triangle will always be 60 degrees. Moving on to isosceles triangles, you can have isosceles triangles that are either right or not, and that isosceles triangle is so because it has 2 legs of equal length. The angles opposite those equal length legs will be equal as well. Something key to note when it comes time to any triangle questions that you may encounter on your SAT. Moving on to the height of a triangle. If it's a right triangle, the height is going to correspond to one of the legs that is creating your perpendicular 90-degree angle. But if you are not given a right triangle, then you can find the height by extending one vertice, rather extending a line from one vertice to the opposite leg, which you will now make your base. And if you draw the line such that it hits it at a 90-degree or perpendicular angle, then you have created a height. The area of any triangle, given a base and a height, is 1/2 base times height. For a right triangle, again, that's going to be the 2 legs, base and height, that create your 90-degree or perpendicular angle. We already discussed hypotenuse, so let's go ahead and move on. Triangles can be congruent or similar. Triangles that are congruent have the same measurements for corresponding sides as well as angles of equal measure. If triangles are similar, and you can prove this based on a little bit of deductive reasoning on your part, then they have certain properties. Let's look at the properties that make 2 triangles similar. Now, triangles are going to be similar if they evince angle, 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 side, 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 or side, angle, side. The first two are really easy to understand. If two triangles have all angles equal in measure, then they can be said to be similar because their opposite legs for each of those equal angles will be in some proportion to the legs in the other triangle. If you have side, 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 that means that your two triangles evince proportionality for three of their sides, all three of their sides rather. If you have side, angle, side, that is saying that you have a proportional side with a proportional side creating a vertice, and in that vertex you are going to have an equal measure for your angle to create side, angle, side similarity. That about does it for a quick overview of circles and triangles, information not found in the reference section before your SAT math section. As always, I want to thank you so much for stopping by Calais Prep. My name is Ricardo Calderon, and I hope to see you again soon.